In today's lesson, we're going to be writing and solving equations. We've already practiced solving equations, but now we're going to write them first before we have to solve them. You may also remember that last unit we wrote expressions, so it's very similar, except we're going to add an equation sign instead of just the expression. So on the first page we have some words for addition and subtraction. We went over most of these last unit, but we just wanted to give you these as you're looking through the notes today and also for your homework. So the ones that we're going to add today is we are going to add words that mean equals. Okay, so we're going to be looking for those words so that we can write these equations. One of them that we see a lot is, so you need to keep your eyes open for that. Now, we do have a few tips for you, and it's things that we talked about last unit, but it mostly involves less than. So just remember that anytime you have the word less than, you have to switch the order. Now, it does not apply to more than. So for more than, you know it's just going to be 5 plus 20. But less than, you cannot write 5 minus 20. You have to write 20 minus 5. Same thing goes from the following less common phrases: subtracted from and taken away from. Those are all 20 minus 5, not 5 minus 20. So let's get into our first example. The perimeter of a rectangular field is 102 feet. If its length is 3 feet longer than twice its width, what are the dimensions of the field? So first thing you might notice is that we have a perimeter. So there's a couple of ways you can do a perimeter problem. One way is with the formula. So the formula of a perimeter is P equals 2L plus 2W. Or you can also draw a picture. So your picture, and then you would have 2 lengths and 2 widths. Either one of those are going to work. I'll use the formula for this problem, and then we'll use the picture for the second problem. So if we know that the field is 102 feet, we're going to plug that into perimeter. So 102 equals. Now, anytime you're trying to solve an equation, you want it to only have one variable at this point. So luckily, this problem is going to allow us to write the length in terms of the width. So the next thing says the length is. Length is one of your words that means equals. So we have L. So we have L equals 3 feet longer than, and you don't need to put in the units right now. We'll put those in our answers. Longer than means plus, so 3 plus twice its width, and for that would be 2W. Now one thing that I didn't do is we need to define our variables. So since perimeter has a length and the width, usually we call the length L. Notice for length I used a lowercase cursive L because if you don't, it might look like a 1. And your W equals width. Now that we have this length written in terms of W, we're going to take all of this and plug it into our formula instead of L. So let's continue on. We've already plugged in 102 for the perimeter, and then we have 2 times. Now instead of writing an L, we're going to come over here and grab what we circled, 3 plus 2W, and then we still have to finish out the formula with plus 2W. And now we just have to solve. So 102 equals 6 plus 4W plus 2W. Combine like terms. So we have 96 equals 6W. I'm going to rewrite that. Divide by 6. And W equals 16. Now one thing about these word problems is we always need to make sure that we have answered the question that was asked of us. And in this case it says what is the dimensions, plural, of the field. So we not only need to find the width, which we did, but we also need to take that and plug it in where we wrote length in terms of width. So we would have the length equals 3 plus 2 times 16. So L equals 3 plus 32. So the length is 35. And now we can go ahead and add those units. And we look back to the problem and we see that it's feet. Okay, on our next problem, I'm going to use the picture because we have another length problem, or excuse me, perimeter problem. The rectangle below has a perimeter of 52. Find the value of x. Well, whenever you have a picture, it's a little bit easier to go ahead and just add up all the sides because we know that's going to total the perimeter. So I'm going to combine like terms as I go. So x plus x is 2x, plus x is 3x, plus x is 4x. Then we're going to combine our constants. So negative 2 minus 2 is minus 4. And that's going to total the perimeter of 52. So the next thing we're going to do is plus 4. So 4x equals 56. If we divide by 4, x equals 14. And since the problem asked for the value of x, that is our answer. And I could have boxed the answer up here just so that we know that we're done. Okay, for number 3, a farmer has 37 feet of fencing to be used to create a rectangular area around his garden. One side of the garden will be along a barn, so it won't need to be fenced. This side is 7 feet long. Find the length of the other side of the garden. So in this case, probably our best bet would be to go ahead and draw a picture. So I'm going to draw a barn because I know this fence is going to be up against the barn. So I'm going to draw the fence out here beside it because it specifically says that one side will not need to be fenced because it's against the barn. So that would be this side, but it also tells me that that side is 7, which means the side across from it is also 7. I know I have 37 feet total. So I know if I add up all 4 sides, it has to equal 37. So we need to give a variable to the other 2 sides. And since it is a rectangular area, we know they're going to both be the same. So we can call them both x. And then we just have to add up. Remember, we're only adding the pieces, not next to the barn. So that's going to be x plus 7 plus x equals 37. Combine like term, x plus x is 2x, plus 7 equals 37. Oops, I meant to show my work there, sorry. Minus 7, 2x equals 30, and if we divide by 2, x equals 15. Now let's go back up and check the problem. It says find the length of the other side, so it is 15. And if we can add our units of feet. Okay, for number 4, Paul bought a student discount card. On the bus, the card costs $7 and allows him to buy daily bus passes for $1.50. After 1 month, Paul spent $29.50. How many daily bus passes did Paul buy? Now, I didn't define a variable on the last problem because it was kind of obvious because I drew a picture. So in this case, since I need to know how many daily bus passes he bought, I'm going to say that P is going to equal a daily bus pass. Okay, so the next thing I'm going to go back and find some important information. So the card costs $7 and allows him to buy a daily bus pass for $1.50. So the daily bus pass is $1.50 each. After 1 month, he spent a total, and I know I added that word, but if he spent that much, that's the total amount. So there's our equal sign. How many bus passes did he buy? So we have to look at the card cost $7 plus $1.50 for each daily bus pass. So $1.50 times P, and the total that he spent was $29.50. So now we just have to subtract So $1.50, P equals $22.50. So when we divide by $1.50, we see that he bought 15 daily bus passes. Okay, 5, Jennifer's saving money to buy a bike. The bike costs $245. She has $125 saved, and each week she adds 15 to her savings. How long will it take her to save enough money to buy the bike? So we want to know how long it'll take her to save enough money. So if she's adding money weekly, we can just say that let it equal W would equal the number of weeks for her to get enough money to buy the bike. So then if we're looking for the total cost is $245, so we know it's going to equal $245, and she starts out and has $125 in savings, and then she's going to add to that $15 every week, and we know the total of the bike is $245. And now we can just solve for the number of weeks. So if we subtract 125, so 15W equals 120. If we divide by 15, if you don't have a calculator handy, you may want to grab one just to make it easier for you. So it would take her 8 weeks in order to have enough money to buy the bike. Number 6, Maggie's brother is 3 years younger than twice her age. The sum of their ages is 24. How old is Maggie? So first and foremost, let's define our variables. So we have Maggie that we're just going to call M. And remember, we're talking about, we'll write Maggie's age. And then we have B, we have her brother's age. So it says Maggie's brother is, so the brother is 3 years younger than twice her age. Now you have to be very careful with younger than because it is just like less than. So we need to switch this order. So we have a 3, and then we know it's a minus, and then twice her age, and we called her M. So the 2 that we are going to have to switch is the 3 and the 2M. So we have 2M minus 3. And then it says the sum of their ages is 24. Well, in this case, that means if we're adding B plus M, or Maggie's age plus her brother's age, it's going to total 24. Now what we actually need to do is substitute the 2M minus 3 in for B in the problem below. Okay, so this is going to make us, right now we have 2 variables in our equation, an M and a B, but whenever we substitute, so we have M plus, now remember, instead of the B, we're going to write the 2M minus 3 equals 24. Now we can combine like terms. And we can solve. So M, we see that we designated that as Maggie's age, so M is 9. Then we can take that and we can plug it in. We can take this and we can plug it in right here and solve for her brother's age. So her brother is 2 times 9 minus 3. So then that's 18 minus 3. So we know that Maggie's brother is 15 years old. And Maggie is 9 years old. 7, a house painting company charges $376 plus $12 per hour. Another painting company charges $280 plus $15 per hour. How long is a job for which both companies will charge the same amount? What will the cost be? So since we want to know how much it will be when they cost the same amount, we're actually going to have to set these equal to each other. So let's call, we'll let X be painting company number 1, and then we'll let Y equal company number 2. And now in this case, because we want to know what it'll be whenever we set them, or when they're the same, we actually need to set both of these companies equal to each other. So in this case, we're going to be setting it up X equals Y. So everything that has to do with the first company will be set equal to everything that has to do with the second company. So in this case, and then we're talking about the number of hours. So we have 376 plus $12 per hour for the first company, and then we're going to set that equal to 280 for the second company plus $15 per hour for that company. Now once we solve for H, we'll find out how much or how many hours it would be for them to have the exact same cost for the company. So if we subtract 12H, 376 equals 280 minus 3H. So now I'm out of room, so we know it's going to equal negative, or excuse me, that's a positive. So positive 3H, and then if we subtract, that would give us 96, and then if we divide by 3, and I'm sorry, I'm out of room, if we divide by 3, that would give us 32. So it'd be 32 hours for the company to have equal, or for it to cost the same no matter which company that you use. Then if we want to know how much that cost will be, we would just need to take this 32 and plug it into one side or the other. So we could plug it in right there, and we would have 376 plus 12 times 32. So if we plug that into our calculator, we get $760 total. So that answers the second part of the question. Okay, if we look at number 8, Justin and Tyson are beginning an exercise program to train for football season. Justin weighs 180 pounds and hopes to gain 2 pounds per week. Tyson weighs 195 pounds and hopes to lose 1 pound per week. If the plan works, in how many weeks will the boys weigh the same amount? What will that amount be? So we're talking about the number of weeks. And what we need to do is we need to, and I could have done the same thing for the one above, is we need to set Justin's weight equal to Tyson's weight and what they hope to gain or lose. So Justin weighs 150 pounds and he wants to gain 2 pounds every week. Tyson weighs 195, but he wants to lose, so we have to subtract 1 pound. 1 pound every week. And now we just have to solve. So let's plus W, because remember you don't have to put that 1 there. So 150 plus 3W equals 195. So if we subtract 150, we end up with 3W equals 45. So after we divide by 3, sorry, I'm not showing my work there. Divide by 3, would take them 15 weeks to weigh the same amount. Then if we wanted to find out what that amount is, we just have to plug it into one side or the other. Probably easier to plug it into Tyson's side, so he's 195 minus 1 times 15 weeks, so really, you don't have to put that 1, but I will. So 195 minus 15 is 180 pounds. is how much they will weigh after 15 weeks. Okay, for number 9, a fundraiser raised $2,400, which was 3/5 of their goal. Write and solve an equation to find the amount of the goal. Now, this one is kind of tricky. The total amount raised was $2,400. So I know it's going to equal $2,400. The hard part is figuring out what to set that equal to. And the key is 3/5 of their goal. A lot of people forget that this word of means multiplication. Okay, so 3/5 times their goal. So I'm actually going to let G equal what their goal was because they didn't reach their goal. So I'm going to say 3/5 times G. Now we can multiply by the reciprocal. Multiply by the reciprocal. And so their goal was, and I'm also going to cross reduce just to practice. 3 will go into itself one time. It will go into 2,400 800 times, and 800 times 5 is going to be $4,000 was their goal. Now you can also do a little check here because if they didn't reach their goal, then you know your answer should definitely be more than $2,400. And then for this last problem, Stanley worked 6 more hours than twice as many hours as Kathleen did. How many hours did each work if they worked a total of 66 hours? So in this case, I'm going to use S for Stanley. And you have to be careful with your S's because they can look like 5. And then I'm going to use a K for Kathleen. So Stanley worked, so we could say S equals 6 more than twice as many hours as Kathleen. So one equation we can use is S equals 6 plus 2 times Kathleen. But then it says how many did each work if they worked together? They worked 66 hours. So for that equation we have to add Stanley's hours plus Kathleen's hours. And we know that that's going to total 66. So here we have another question where we're going to have to substitute in the 6 plus 2k. We're going to have to substitute it in the second equation for Stanley, for S. So we have 6 plus 2k, that's what we substituted. Then we finish writing plus k equals 66. Combine like terms. 6 plus 3k equals 66, and we can solve from there. So we have 3k equals 60, and if we divide by 3, k equals 20. Sorry, it's not wanting to write for me. So that means Kathleen worked 20 hours. And then we just have to plug that in, and the best place to plug it back in is right here. So S equals 6 plus 2 times 20. So Stanley worked 40 plus 6, 46 hours.